Good morning, everybody. Today we will discuss the next reactive intermediate of a chemical reaction, that is the carbene. We know that carbene are highly reactive carbon species and carbenes are divalent carbon species. Some of the carbene are highly stable, so that stable carbene can be isolated from the reaction medium, whereas some of the carbene are less stable, so we cannot isolate that carbene. And carbene have 6 electrons around the carbon atom, so that's why carbenes are electron deficient in nature. And carbene have a sp2 hybridization, and there are one p orbital which is does not involved in the hybridization is also exist in carbene. Since it have the 6 electrons around the carbon atom, 2 of the electron which is not involved in the bonding is also present in carbene. So the 2 from one CH sigma bond, the other from next sigma bond. So total number of the electron is 4, and the remaining 2 electron is coming from the non-bonded electron. So the total number of the electron in carbene is 6. So that's why it is electron deficient, and carbenes are highly reactive to achieve the 6 electron pair system. Carbene can be divided into two different types. First one is the triplet carbene and the second one is the singlet carbene. As we discussed earlier, we know that the hybridization of the carbene is sp2 hybridized. There are 3 sp2 hybridized orbitals are present in carbene. Two of them are used for bonding with the hydrogen here, and the remaining one contain one of the electron in the non-bonded electron, and the p orbital which is does not involved in the hybridization which is exist perpendicular to the sp2 hybridized orbital, and this p orbital also carry one electron. Whereas in the singlet carbene, this pair of the electron, that means the non-bonded electron exists in one of the sp2 orbital and they are paired. While we are comparing the stability of the triplet carbene and singlet carbene, triplet carbene are more stable than singlet carbene. Since the triplet carbene having lower energy than that of the singlet carbene, and in the singlet carbene both the electrons are exist in an unpaired state. So that's why there is a little repulsive force is existing in triplet carbene. Whereas in the singlet carbene both the electrons are paired and they are exist in a single orbital, so that it suffer more repulsive force. That's why the triplet carbene is more stable than that of the singlet carbene. But the energy difference between the singlet carbene and triplet carbene is only around 1 to 8 kilocalorie per joule. Now we are moving into the different method for the generation of the carbene. So first one is the generation of the carbene from diazoalkane. We know that all the diazo compound are highly unstable and it is highly reactive. So first of all, a diazoalkane undergo the decomposition in the presence of light or heat and to produce the carbene and a neutral molecule nitrogen. So second method is the sulfonyl hydrogens. That is the generation of the carbene from sulfonyl hydrogens. First of all, a base will attack the most acidic proton in the sulfonyl hydrogens. Then it undergo the rearrangement and to form an diazoalkane, and finally the diazoalkane undergo the decomposition and to form alkene, carbene. Next method is the halides. So the halides, if you treat the halide with an base will pick out the most acidic proton and to form a carbanion, and this carbanion undergo alpha elimination, that means elimination from the same carbon atom, and to form a carbene and Cl- ion. Next method is the generation of the carbene from tosyl hydrazone. So we know that the tosyl group are easily living group, best living group, and if we treat the tosyl hydrazone by using a base, it will pick out one of the most acidic hydrogen and a carbanion is generated, and this carbanion undergo the decomposition in the presence of heat and to form the stable diazo compound, and it will easily undergo the decomposition and to form the carbene. Next method is the generation of the carbene from ketene. This is the structure of the ketene, and ketene undergo the decomposition in the presence of heat or light and to form carbene and also form the carbon monoxide. Next is the reactions of the organic reaction in which carbene is involved. Carbene usually undergo the three different type of the chemical reaction. First one is the addition, in which a carbene electron deficient carbene is added to a multiple bonded organic compound. Here it is an alkene, and carbene is generated in the decomposition of the diazo alkane, and this carbene is added in between the doubly bonded carbon atom. So we will get a cyclopropane as the final product. Next type in which the carbene is involved is the insertion reaction. Carbene, most of the reactions of the carbene are insertion reaction, in which the carbene is inserted in between the C carbon and hydrogen, or sometimes it may be carbon and X. So carbene is inserted in a sigma bond, and this method is used for enhancing the chain length in a hydrocarbon. See here, in which a carbene is generated, it may be a singlet or triplet, and it is added in between, inserted in between the carbon and hydrogen, so the chain length is increased. Next method, carbene also undergo the rearrangement reaction, so in which first of all a diazo compound is generated, and it undergo the decomposition and to form a carbene. It undergo the rearrangement, and we can migrate the alkyl or phenyl group. So in this example we can generate three different type of the product by the carbene rearrangement. Now next is the famous important rearrangement, that is the Wolff rearrangement, in which carbene is generated. First of all, a carbonyl diazonium compound is treated, and it undergo the decomposition by the liberation of the nitrogen, and a carbene is generated, and this carbene is finally undergo the rearrangement and to form a ketene. So this rearrangement is known as the Wolff rearrangement. I hope that you understood the structure of the carbene and the stability of the carbene and the reactions of the carbene and what are the generation method for the carbene. Carbene can be stabilized by the presence of electron donating substituent or any substance which can pushes the electron towards the central carbon atom, which are electron deficient. I hope that you understood the concept. Thank you.